here? Why do I get to present to you? Well, maybe in 2012, late 2012, a good friend of mine and I started the Los Angeles AWS Users Group. We did not have as many people as are here tonight, so this is actually a great success. It was 4 of us. We were on a boat in Marina del Rey eating some Chinese food, and we decided to talk about Amazon. And so that's how we got started in the meetup scene. I spend a lot of time, pretty much every day, talking to customers across all sorts of verticals about what they're trying to do in Amazon. A lot of it is, how do I move my ERP? How do I move SAP? How do I move AD? And those are, inside of a business context, that's kind of important. We have to do those things. Those are our business critical systems. But the meetup is kind of fun because it lets us have a little bit of gratuitous fun and explore and do different things. And that's what tonight will be about. We're going to talk about Amazon Rekognition. Anyone seen it, played with it, heard about it at all? Anyone? A couple? All right. So it's a fun service. It has changed a whole lot since the last time I did this talk. We did this back in October, I think it was, and the product is a very different beast today than it was back then. So maybe real quick, just again, this is Campus. I think most of you are familiar with this. I've had the pleasure of spending a lot of time on campus with ITS and the team. I enjoy every moment of being out here. In fact, my colleagues are usually phoning me like, when are you coming back? So, it's just great to be out here, especially to be with a team like the Cal Poly team, who are really sort of very interested in pushing and migrating to AWS and doing it the right way. So, Rekognition. This is not a new thing. Humanity has been doing visual recognition since they were able to make images. And so these are some very, very old handprints that were a little bit of powder and a little bit of water, make a handprint on the wall. And we started telling stories through images. And that's what ultimately Amazon's Rekognition service is all about, is enabling us to take images, to interpret them, to understand the story. But it has its roots in thousands of years of history. So Amazon has a suite of AI services, AI, artificial intelligence. There's a lot of black box stuff that we don't get to see that's happening behind the scenes, but it gives us some extremely powerful things. Rekognition is not the only AI service that Amazon has. They have Polly, they have Lex. More recently, they have Transcribe. They have a bunch of other ones out there that are newer. Again, this talk, the first time we did it, those things didn't exist. These services have, as much as they are AI, there is still some growth to go in them. So Amazon will agree and sort of attest to their approach to things is, let's build the product, let's iterate, let's carry on, let's iterate again. And that's important because one of the things that these AI services don't have is a really great feedback loop, and we'll talk a little bit about that in just a bit as well. But we don't get to train the model. So we can't tell it, yes, you got that one right, you didn't, you got that one wrong. We don't have that feedback loop today. So Amazon will iterate over time.
In one sense, what are Polly and Lex? What do they do?
So Polly is speech to text, text to speech. So we can type in a bunch of characters, and it will speak it in one of 50-something different accents or dialects or languages. So you could type in "Hello World," and we could say, "Hey, say this in Korean," and it will say it in Korean for us. Lex is kind of a chatbot framework. So if you think about your Amazon Echo and you talk to Alexa, there's a framework, there's an interaction. We say, "Hey, Alexa," and Alexa, the blue light lights up. We can start talking to it. It sometimes understands us. It does what we ask of it. All of that is being managed through a chatbot framework, and Lex is essentially that framework. So what is Rekognition? Rekognition, very simply, is a service that we feed images into. More recently, we can actually feed video into it as well. And we can start to intuit stuff out of it. The recognition service can say there's a man in that photo, there's a woman in that photo. That man he appears to be happy, or he appears to be angry. It can start to intuit some of the stuff based on the image. It can do face analysis. We can figure out happy, sad, has a beard, has glasses, things like that. Scene detection, we can tell what objects are in the scene. Is there a skateboard in the machine? Is there a car in the scene? Is there a sailboat? Is there water, maybe a river or an ocean? All of those things, recognition, you could feed it in and say, hey, tell me what's in the scene, and it'll come back with all of those objects. Celebrity recognition, so we can feed it a bunch of faces, and if they're celebrities, and if Amazon decided they are, then they might be discovered as a celebrity. So if you were to feed it Jeff Bezos' picture, it will say he's a celebrity and this is Jeff Bezos. If you send a picture of Kim Kardashian, it will get that correct. But if you send it a picture of Fernando Alonso, who is a Spanish Formula One driver, it doesn't know who he is. It also doesn't know that I'm a celebrity. So, image moderation. This is in production today by a lot of customers. Anyone photography sort of enthusiasts, amateurs, ever seen the website 500px? Yep, so 500px, they have used Rekognition's image moderation to automatically tag something as adult content. And we'll walk through that in a little bit as well. This is a cliff, maybe 4 or 5 miles from our house. Any of you familiar with Point Vicente in Palos Verdes? It's actually a Coast Guard base. They have a helicopter pad out there. They have the lighthouse. And you can see we fed it this picture, and it's saying there's things like there's a beacon in there. Well, I would argue that a lighthouse is a beacon. It actually says there's a lighthouse there. It says there's water, there's palm trees, there's plants. So it was able to figure out some details about the scene. Couldn't tell that that's Catalina Island in the background because it doesn't know where in geography this picture was taken. It just knows there's some water. And you can see that we get some confidence scores. So every time it says, hey, I see this thing, it tells us how confident it is that that thing is what it thinks it is. Very simple. And I'm going to do some demos and show you how you can actually play with this from the Amazon console. You don't have to write any code to play with Rekognition. Although when you start to write code, you can make some very, very interesting things happen. Facial analysis. This is me out in the Long Beach Harbor. We're sailing, a bunch of us were sailing. So we can look at the face and we can make a bunch of determinations. So it looks like a face. Yep, so got that one right. Appears to be male. Got that one right. Age range, it's a little bit broad. I would have liked to have seen it a bit narrower, but it got it right. Smiling, it was 97% sure I was smiling, maybe 69% sure I was happy. I'm not quite sure how you can be smiling but not happy, but but these are the types of things that it's going to give you a score. So wearing glasses, and it's like, yep, we're pretty sure he's wearing glasses. Facial recognition or facial analysis, it can tell us a lot about the person that we're looking at. And Rekognition does all of this again. All of this comes packaged in the SDKs. We can play with this directly from the console, and you can sort of experiment, and it's pretty impressive just how good it is, especially just you can take your own photos, upload it from your computer, and play with it. So it will try and match faces, and this is what our demo is today. So you can see that there's 2 different pictures of me, and it's giving me a confidence score. It's 95% sure that same person. There's a bunch of other information that the SDK sends back. It'll tell us about the bounding box, so where in space it found a face, things like that. And it'll say, okay, yeah, we think this person is the same person, yes or no. If you use the SDKs, which my demo that I built does use, we can tune the confidence level. So we can say, do not consider this to be a match, if the confidence number is below a certain level. The use case is some sort of membership, let's say a gym. And let's say we didn't want to give our gym members any more a card. When they come, they check in with the card, and then they go into the main area. Maybe we want to take pictures of them and recognize them. In that case, being fairly sure of identity is important. We want to make sure we're we're letting the right people into the gym. If you did something with law enforcement, I would say this may or may not be the tool for you just yet. Maybe you'll augment this with a little bit of OpenCV or something like that. But for general sort of tools and applications, this may be very good. It'll give us a confidence score. It'll tell us if it's the same person with or without sunglasses. I've done this with sunglasses. I've done it with my regular prescriptions. I've taken the sunglasses and the glasses off, and it was able to figure out that I'm still the same person. Why can it do that? Well, if you go back a slide, you can see this is what Rekognition is looking for. So it's looking for some landmarks on the face, and it's measuring the distance. It's doing a couple of calculations. Now, when you use Rekognition from the SDK, we get a bunch of JSON that tells us about these landmarks and the bounding box and where it's finding faces. If you play with this in the Amazon console, you will see these overlays that help us understand what it's doing. But for the most part, the overlays, they're not all that helpful to us. It doesn't really give us a lot of information. It's just interesting when you're debugging to try and understand what it's seeing and how it's working. So if there are multiple faces in the picture, it will detect them all. If you're doing a face match detection, it will work with the largest face in each picture. So if there's multiple faces, it will default to the biggest one it finds in each picture first. You can tell it to match all the different faces as well. So you can go through all the faces and do a detection and see if we've got a match. So maybe you take a single picture of me, and then maybe there's a group picture that I'm in that group, and you say, am I in that picture? So you would have to iterate through all the faces and decide if I'm in that picture or not. And so Rekognition does that for you. It can do that work. The glasses can be a little bit hit and miss. Spectacles like this, no problem. It's pretty much going to work. Sunglasses, it depends. The other thing that we'll talk about a little bit later is that unlike iPhone X, which actually it projects a whole bunch of light onto your face, and they do landmarking in 3 dimensions, so that they can tell that you're a real face. Rekognition, I can take a picture of a picture, and actually it will work. It's just doing these same calculations. It sees a face in the picture. It's all 2-dimensional, so it can only do flat dimensional sort of landmarking and figure out what's going on. Is this person the same person? So celebrity detection, we'll feed it a photograph and we'll say, who is this person? And it'll come back and it'll say it's Jeff Bezos. Amazon claims there are thousands and thousands and thousands of celebrities, but that may be true in the US. It is certainly not true in other parts of the world, and there's definitely not comprehensive. So you put Bill Gates in there, it's going to be fine. You put Steve Jobs in, no problem. You put the Kardashians in there, no problem at all. Pretty much any TV character you can think of, it's probably going to find a match. But if you think of maybe some sort of thought leader in a space that, let's talk about a university setting, maybe a really well-known professor, he may not be in that database just yet. So image moderation, the use case I already mentioned to you, 500px. When you are a member on 500px, you upload a picture and they ask you, is this adult content? Interestingly, not everyone says that adult content is adult content. They should, but Terms of Service says we should, but not everyone does that. So this is a way for them to sort of analyze the image, detect what's going on in that image, and then decide whether or not they want to tag the image that way. We could have a use case where somebody posts an image. Who uses Slack? Anyone Slack? Lots of Slack users. So someone posts a picture that may or may not be appropriate. We could have a Slack bot moderate the image before we allow it to get posted. So lots of use cases. Student-related sites, apps, particularly K-12. Let's sort of think about that as a scenario. This could be very, very powerful stuff. And we can talk about whether you can see some of the tags that they have. They talk about suggestive, whether it's swimwear or underwear or whatnot, and then you can sort of say, hey, we tagged this, we've detected it's adult content, and you could say, do you want to view the content? Press the button, and then you force the user to make a decision. But from a platform perspective, you're trying to do the right thing. So talk a little bit about the architecture for tonight's demo. I'm going to show you some code. If you look at the comments for tonight's meetup, I put a link to Test Pilot. So if you put in your name and your email address, you can. I will add you to the Test Pilot. You can download this. If you're an iOS user, you can download the app, play with it later, experiment with it. We're also going to be releasing the code, so if you want to write your own code, we'll be releasing that probably in a GitHub so that you can take a look at how it all works. But walking through it, here's what happened. All of you guys RSVP'd to the meetup, and most of you have a profile picture that looks something like you. Not everyone. And in most cases, those were what Rekognition considers high enough res. And so one of the things that you'll have to think about is when you're testing these things, what is high res? And the interesting thing is even 300 by 300, which is actually a very tiny little image, will work. I've seen it work. What high res is exactly, I'm not so certain about, but the use cases talk about do it as high res as possible. On the back end, I have a Lambda function, and for those of you who don't know, Lambda is a serverless architecture. It functions as a service, and I fire that thing off every hour. So every hour, I go and send a REST request to meetup.com, and I go and see who's in the RSVP for the event. I get your name, and I get a photograph of you, your profile picture. And I send that information to Amazon's Rekognition. We index that information. I get an index ID, and I store that in DynamoDB in a table. So if you, this thing here, we're sending REST requests back to Meetup. We're trying to get your name. We're trying to get a photo of you. And we're making sure that it's this particular Meetup that we're talking about. The indexer puts information inside of a DynamoDB table. It puts the Rekognition ID that we generated, and it puts your name in that table. And this demo is not fully fleshed out, so it's also intended to be able to check you in, like, hey, you're here at the meetup. That functionality does not exist at the moment, but that's kind of the idea. Rekognition over here, that database, it's sort of a black box. It's an SDK. We feed it information. It gives us back IDs. It will tell us if it cannot index someone for any reason. Next thing that happens is at the mobile user level, we get an app, and we open up the app. We take a picture of ourselves, and that picture gets sent back to Rekognition. Rekognition says, okay, the photo you've just sent me, I think I found that person, and we get a confidence rating that's listed with that. Or if it couldn't find anyone, it'll just say no match. There was nothing in there to match against. The mobile app sends another request to the API gateway. This is another Amazon service. API gateway, if you have ever been involved in building and maintaining APIs, you know that you normally have to put some sort of a manager in front, and it's usually things like tokenizing, making sure that this person has authorization to use our API, it's to expose the API, like what services and calls can I make to the API. What API Gateway does is it does all that work for us. We don't have to think about that. We just we tell API Gateway, here I have this API, this is its name. You can also namespace it into dev, prod, QA, staging, anything you like. And you can tell it when you see this call, send it to this endpoint. And in my case, I'm sending it to an Amazon Lambda function. You could send it to a web server running Apache Nginx or anything else, for that matter. Doesn't really matter. API gateway is just a relay point. It's about authentication, authorization, tokenizing, aggregating. How many times is this API getting hit? Things like that. We have another Lambda that queries DynamoDB. When Rekognition responded back to the app, it said, I have this match. Here's the ID that goes with the match. The app then sends a request through API Gateway with that ID, and then the Lambda function checks with DynamoDB, do you have this ID in there and what's the name? The name comes back from Dynamo. The Lambda function returns back to the mobile app. The user gets the response that they're looking for. So basically, in a nutshell, that's what the demo is that we're going to be showing you tonight. Before we do that, I'm going to show you a couple of other things from the Amazon console and how it all works. Bear in mind, the Rekognition suite actually changed a lot. The first time I did this, all it could do was image recognition. Now it's doing video analysis as well, and in real time. It does very interesting things. So you could programmatically tag a person in your video, and you could say, follow that person. And it will even follow the person off scene, and when that person comes back in, it will pick them up and continue following them. And you can then get a lot of meta about what that person's doing at all different stages throughout the video. So very, very interesting stuff. Very powerful. When I first started talking about Rekognition, that stuff didn't exist. So
Can we ask you a quick question about
yeah?
the architecture? Could you go back one?
Sure.
So I'm looking at all those services you're using,
Mm-hmm.
and in my mind, I think you own a server somewhere where this process is running.
Mm-hmm.
Is that an accurate model?
Nope. There are no VMs. I don't have any virtual machine in this environment. Everything here is a hosted service by Amazon or a serverless function in Lambda. So I don't have a virtual machine.
Yeah, and I'm just trying to think, well, you're saving it somewhere, and where is that?
So I have persistent data, long-lived data in the DynamoDB. That is a managed NoSQL database. So there are machines behind that, but if I go to my Amazon console, I will not see virtual machines in there. This is abstracted away from me. It's just an endpoint. The other persistent storage over here is Rekognition. So Rekognition maintains a database of all the images I've given it to index. Again, I don't see a virtual server in my console. There are servers. I mean, even serverless isn't serverless. It's just that I get serverless. The best way to sort of think about it is the closest cousin is like Docker and containers, things like that. But again, I don't have to manage the cluster. I don't have to provision it. I don't have to think about how much memory, how much CPU. I just hand it a piece of code and say, go run that. And you need to figure out, Amazon, you need to figure out how to run this for me. So pretty powerful stuff, and especially when you think about the application we're talking about. We've collected photos, we've indexed them, we have an app that's talking to a back end that's querying this index, and there are no servers. So it's really kind of powerful stuff. And this is pretty simple. We can do amazing things with serverless technologies. So best practices. Images with good lighting will always work better. It's just the nature of the beast. If it's an extremely bright day out and I'm in a shadow and you take a picture of me, Rekognition may not be able to see all those landmarks it's looking for to be able to do facial analysis or image detection. Consider pre-processing your images. So think about boosting contrast, think about boosting sharpness. Don't use images that are too small. That's not very helpful. If you're doing things like facial recognition, try not to. If the sample you want to scan, try and make that a single person in the photo. Otherwise, the indexer just really doesn't know who it's. It's indexing faces. It doesn't know who it's got. So take your DMV photo, take that picture of you. And something like that. If I'm trying to train this thing, what Kevin Epstein looks like, I'm not going to send it a group photo. So your indexes, you get an external ID, and this can be anything you like. I discovered that it can be anything that you like as long as you behave within the rules. Some of the rules are no special characters, no spaces, none of that kind of stuff. So all lowercase, things like that. The external ID is also, it is free text. You could put alphanumerics. You could put my name as the ID, but that's not a great way to go about it. So generate an ID. In this case, the ID that when I index a face, I just took your Meetup user ID and used that as the number that I would index as the ID. And then store the rest of the meta about the person in some sort of database, whether it's DynamoDB or RDS. RDS, for those of you who don't know, it's just a managed database service. So it could be MySQL, SQL Server, Oracle, Postgres, anything like that. Don't crop too closely. So sometimes I just say to you, like, hey, don't feed this thing a group photo if you're trying to train it who Kevin Epstein is. But if that's your sample, you have to be careful about cropping too closely because, again, this thing uses landmarks. And if you chop off the top of my head and maybe you chop off an ear, we start taking away landmarks that this thing can use. Avoid overlays. So this is actually something else that Rekognition can now do, is it can actually look at overlays. It can see text in the overlays. There's interesting things that it can do with that. But for the purpose of training it, when you're trying to recognize a person, avoid overlays. Hats sometimes work, sometimes they don't. That's going to change your confidence numbers more than anything else. If it's a scene detection issue, then maybe you don't care about a hat because, like, Rekognition will tell you, yeah, there's a hat in this picture. So think about your use case. Think about what you're trying to get Rekognition to do, and then depending on that, you need to feed it, images that are going to be more likely to succeed. When you do face comparisons, when you're doing like, is this Kevin type of queries from Rekognition, you're going to have to play with the confidence number, and you're going to have to decide whether or not a 75% match is appropriate for you. The first time I did this demo, I said, well, no, I want to be really sure it's Kevin. So I set the threshold at 95%. And from time to time, a straight-on portrait shot of myself wouldn't match. And then it would match, and then it wouldn't match. Changed the number down for tonight's demo. I changed it down to 75%. Seemed to be a really good sort of working base. It's mostly right, although it still gets things wrong from time to time. And this confidence number is going to help you tune out the false positives and the false negatives. So demos, this is the app that I'm going to show you in just a little bit. Fun story about this. This talk, when I first presented it, was a reason for me to learn Swift programming. I'd never done it before. So some of what's going on behind the scenes, we're going to release this Swift code. Again, you can play with it, open it up in Xcode, play with it, put it on your device. And I do have this as a test flight app, so if you do fill out the form, we'll get you added to the test pool and you can download it onto your phone. Unfortunately, it doesn't work for Android, only iOS. Word of warning, I mentioned it before. Sometimes demos go wrong. So this was when we were testing and preparing for today. We were trying to debug why all of a sudden, where for as long as the last couple of weeks, the app was recognizing Darren without a problem. And then all of a sudden, he got a null. So this picture over here is Darren on his phone taking a selfie of himself and submitting this to Rekognition, and it came back null. So it couldn't make a match. The interesting thing is, I took a picture of his cell phone, and I got a match. So sometimes things go wrong. The lesson behind that is when you write code, build really good try-catch sort of code blocks so that you can trap for different scenarios. If we have a failure, we can manage the failure. We can give the user something useful back, maybe something more useful than null. And so the running joke for the rest of the afternoon was if someone ran the app and it worked, then that person was not null. Cool. So we're going to run the demo and then ask questions as we go along. My Lambda function makes an API, a REST API call to meetup.com. It asked for all the RSVPs to this particular meetup. It asked for your photos. It asked for your names, and we indexed that away. So recognition, it's available from your console. So I really sort of encourage you to at least play with it at the console. You don't have to do any kind of coding to make this happen. And we can do things like this. This is object and scene detection. So this is a sample photo that they make readily available, but we can upload our own photos if we want. And you can see here it's telling us a little bit about the scene. There's a skateboard in there. It's pretty sure that it knows about that. It says that it detected sport. So skateboarding is being classified as a sport. There's humans, there's people, there's a person. And this is what the request looks like. We sent it, an image request, and said, tell us a little bit about, why can I not make that scroll? Tell us a little bit about that image. And then we got a response. And you can see here, for each tag that it gave us, it gives us a confidence number, all the way down to, there's a bumper in this picture. It was flipping a coin, basically, and saying, maybe there's a bumper in the picture. And it probably did that because, well, it's all cars, so cars have bumpers, so we'll take a wild guess that there's a bumper in this picture. Image moderation. So, again, in this case, the results, there are no moderation tags in this particular picture, so we're pretty sure that this picture is safe. The next picture, you're going to get a moderation one where it says, okay, this may be suggestive, swimwear or underwear, and we can then programmatically say, hey, if you want to see the image, click the button, and we can make it appear. So face analysis, you saw examples of this already. Again, for the purpose of sort of troubleshooting and playing with the demo, they give us the bounding box, they give us the landmarks that they're looking at. In this one, it's kind of guessing where the eyes should be more than actually knowing where the eyes are because it can't see through the sunglasses. And we get some results. So it appears to be a face, appears to be a female. Age group, again, 26 to 43. I think that's, when your guesses are that wide, it's hard to be wrong. Smiling, pretty sure she's smiling, wearing glasses, things like that, pretty sure. This is where things get more interesting. And you can see that recognition knows that there are 3 faces in here. And it's put the bounding boxes for each one. It's put the landmarks for each one. And over here in the result, we can iterate through the results. So if you recall, I said to you, it's going to look for the biggest face in the picture first. And so that it defaulted to the guy in the middle. But we can iterate through, and you can see that, again, there appears to be a face, age range, smiling, happy, not wearing glasses. And you can, again, here we've got another age range somewhere between 11 and 18. But the point of this particular demo is we can actually have a group photo, and it will know that there's multiple faces, and it's going to landmark them out. And then programmatically, we can iterate through all of these faces, and we can start to make determinations about them. So
it's interesting it identifies the little person as a girl. It's just looking at the face.
yeah. So yeah, I mean it's pretty good at that. I haven't seen it miss, and calling too many guys girls and too many girls guys. So it seems to be pretty good at that stuff. So it is very interesting that it's able to do that. So celebrity recognition, of course. It's good. If it didn't get this one right, I suspect that Werner Vogels would be in trouble. And again, same with Andy Jassy. I'm sure most of you recognize the face. He's up on stage for every reInvent and every summit. But we can also upload an image, and I think I have Fernando Alonso, Spanish Formula One driver, and it doesn't know who he is. The rest of the world does, but recognition doesn't. Formula One apparently isn't all that big in the US. I grew up in South Africa, so I've been watching Formula One pretty much for as long as I can remember. Face comparisons, again, very interesting things can be done here. And so you're going to see here on the left, we have the reference face. and we are looking to see, like, hey, does this face exist in the group photo? And we have a 98% certainty that the face on the left is in that group photo. You can also see that it tested all the other faces. So does this face equal that face? The answer is no. And you can see, again, same sort of thing over there.
Quick question, if you don't mind, Bob.
Sure.
So for celebrity faces, it would kind of make sense because there's so much data, so much machine learning on every different angle of the face, right? For example, if it just saw this girl's face, it's in the second picture you can't really see the right side of the face. On the first picture you can see a little bit of that.
Yep.
So if it doesn't know that side of the face or that angle of the face, how can it partially, I guess, take that? Because it's only looking at half the parametry.
So there are some inferences being made. So in this face, we haven't lost all of the other side of the face. So it's trying to detect things like angles, and it'll make adjustments for it and make inferences for it. But the more those angles become oblique, the less the confidence is going to be, and it'll report that way. If we take the second photo, so again, we're going to do this one and say, are those two faces in, is that face in there? And interestingly here, you can see the sample actually has more than one person in it. But again, if we apply the rule of the biggest face in the photo is the one that we're going to default to and sample first, that's why this can still work. And interestingly, this is also a slightly obscured landmark. If you look in the photo over here, her right eye is somewhat obscured, but we can make a couple of inferences and figure out who it is. And then we can figure out that the others don't match as well.
Can we upload more than one image for other reference?
So you could. I mean, programmatically, you could cycle through hundreds, if not thousands, of images. It won't change the accuracy. It won't change the accuracy. It'll go as fast as it can go, but it won't impact the accuracy at all.
If I want to, upload multiple images from just one person, as a training image, so that hoping that I can improve accuracy of the resolution, and you're saying that same thing accuracy?
Well, yeah. So one of the challenges with recognition right now, at least in my opinion, is that I cannot give it one photo of myself and say that's Kevin Epstein. It makes no difference to the accuracy if I give it 100 photos of myself. It's not going to improve the accuracy because what's happening is each one of those 100 photos will just be indexed as another face. And I also have, again, other than through my own, what I do and say, okay, that ID equals this name, recognition doesn't know anything. It just says, okay, this face and that ID number are the same. Yep. There was a question. Yeah. So. Yeah. So, for example, if these two were the same face, and in this case we clearly can tell it's not, but if they were, I don't have a mechanism today to tell recognition, hey, you got this one wrong. I can't tell it that right now. There was a question over here.
Like, say, the girl that you're actually comparing to, like, whether she's not.
Yeah, I mean, if there's a well, let's do this. And it's just like, so it doesn't appear. Yes, I would say that I would argue this is probably more image processing than true AI. But there is some amount of AI happening, certainly is learning something. On the back end, Amazon are doing things to help it learn. I wanted to show you this as well. Again, it can detect text in an image. So I have a sample. I've got a screenshot that I wanted to share. So this one here. This is the splash screen for the app that we built. And you can see it can read special fonts. It's getting that all correct. And it's showing me the bounding boxes where it's finding these words. What was interesting to me on this one was that it clearly knows what numbers are, and at the top left-hand corner it showed me that there's a number over there, but it ignored the number at the bottom. So I don't know what that's about. I need to dig into that a bit more, but it was an interesting sort of observation. It came back. We could feed this thing number plates, and it's going to come back with responses, things like that. And then video analysis, really quickly, I'll show you what this is doing. The video is going to start playing. As it's playing, it's going to say it's found people, it's found celebrities, what activities are happening. There's an audience, there's a crowd, there's speech, there's furniture, there's a beard in this thing. And it gives us a little bit of meta about what it's seen in this. So you can do this in real time. I've even seen this work with streaming video, which is kind of interesting, kind of impressive. There is obviously some amount of lag because the video is playing and we have to send this to recognition. It has to think about it and come back with an answer. I've seen the lag be as small as 2 to 3 seconds, and I've seen it grow to as much as 15, 20. But it's interesting. So that's just the walkthrough on the console. Everything I just showed you, if you have an Amazon account, this is in your account. You can go play with it right now. So I recommend you do. Question?
Actually, back under objects and scene detection.
Mm-hmm.
Does it feed back? I haven't done it yet because like the location of the item it's finding, say, if you had a tennis ball in the upper left, will it feed back? You know, say it recognizes it's a tennis ball. Will it tell you, yeah, that's 200 pixels down?
So I can actually show you. I have to download the response. I have a sample JSON response that I can show you, and it goes back to those bounding boxes, and it'll tell you where in the image it found something.
Okay.
Yep.
So earlier we were just talking about how it's more like image processing than machine learning. So let's say we have a different object that we want to train, right? So I guess is there another training process? So like for a skateboard, right?
Yep.
Obviously it has different like metrics than a face. So
Yep.
the face we saw has like the eyes, the nose, and then the smile. But for a skateboard, obviously it's different. For a tennis ball, it's different. So I guess is that something that's manually done for every object? Like that can't be possible, right?
So every time we use recognition, I think there's an engine behind this, and Amazon gets stuff, and they can start to train it some more. We don't have a mechanism to train it, so I cannot tell recognition that this was a tennis ball, this was a softball, this was a baseball, this was a cricket ball. It's going to probably come back and say ball. Today I don't have a way of training it better than that.
Have you tried with age yet for the facial analysis? Like if you had a picture of you as like a teenager or something, and then more recent photo, have you tried that?
I haven't tried it yet, but it'll be interesting to see. I did try for face matching. I've tried younger and older faces of the same person, and it was pretty good about that. And that's primarily because your landmarks don't change that much. Unless you take of, let's say, a 4-year-old and a 60-year-old, landmarks are going to be quite different. But if you took as a 15-year-old and a 40-year-old, they're not going to be that different. So that worked pretty well. So again, all of this is in your Amazon account. I really recommend you go and play with it, upload your own sample pictures and images. And what I wanted to do now, really quickly, is walk you through just a little bit of the code that I have here. So let me see. Let's go with this one, and let's see if I can make it bigger for you. I had to obviously sort of prepare it, and I was just testing with a single image. How do I index a face? And so I wrote this piece of Python. And that's everything you see on the screen. That's all it takes to index a face. Excuse me, with using Python and Boto, just 28 rows of code, and we can index an image into recognition. Pretty simple stuff. There's really nothing fancy here. basically created a little function called index faces. You will see that I need to feed it an image byte array. So we load the image. You can see here we load an image, and we convert it to a byte array, and we feed it we feed recognition this byte array. So byte array is just basically a numeric representation of the picture, and because recognition is basically what it's doing is it's taking a mathematical representation of the picture collected as a bunch of bytes. We make a connection to the Bodo client. We tell it we're connecting to the recognition service. We tell it which region we're going to be in. You can see here we told it it's US East 1. We tell it that the image is the byte array that we've created. We tell it which collection. So recognition manages multiple collections. And a collection is essentially just a database of faces. So we tell it which collection we're adding this image to. We give it an external ID. So ID of you can take this ID from meetup.com or somewhere else, wherever you get an ID number from, and we tell it which detection attributes to actually index into the database. So we can narrow this down and make it just one or two attributes, or as in this case, I've just told it all the attributes. So just send it back, and then just respond back to me with with the record. And so, if we were to run this, we would get a response. It's going to be basically some JSON. See if I have it.
Bodo 3 is the Amazon library.
Bodo 3 is Amazon's Python SDK interface. Yep. Bodo is actually a really, really good client library. Very, very powerful. Quite often you will see things like Amazon's CloudFormation doesn't have all services on day one. I have yet to run into a feature or a function that you cannot address with Bodo 3, so pretty much on day one of that feature or function's release. Let's see if I've got it. This is just a quick example of the response JSON I get when I do a face match. So you can see here searched bounding box. You can see what the width was, where the top was, where the left was, what the height was. So to who asked the question? You asked the question. This is telling me where on the image it found a face. So in this particular case, it's also telling me that the confidence was 99.999, which is pretty good. Each face gets its own ID. Recognition assigns this ID to the face. I can also give it an ID which I don't believe is actually indexed, not showing up just here. And you can see that the external ID, I just put my name, so that I could, instead of a random bunch of numbers that I wouldn't easily be able to recognize, I put my name there. And again, remember I said to you that it doesn't like spaces, so I had to hyphenate that. And then it just gives me a little bit of matter about the response itself, so what the HTTP headers were. These may or may not be useful to you. Quite often, this is just stuff you don't really care about.
Kevin, where does the authentication that says, like, what if I ran this code and it wouldn't let me use your services? Where's that?
So, great question. In the iOS app that I built, we use an Amazon service called Cognito. And Cognito will authenticate an anonymous user on the app. And it will give that anonymous user a certain amount of rights and privileges. And when that user can, in this case, can contact Rekognition directly, it cannot contact DynamoDB directly. And in fact, it cannot contact anything else directly, the app. It can only talk to Rekognition. Everything else gets brokered through the API gateway, and that one I've said anonymous is fine. So that's pretty loose. But if you were to try and invoke my Lambda function, it wouldn't work because you can't authenticate. Show collection. So this is basically super simple way of showing everything that's in a collection. I can actually run this code for you, and you can see what it will do. Let's make that a little bit bigger, and if I go dot. So if we say show collection, you can see here again, you can see each one of the, where is it? Each one of these responses is indexed in Rekognition, and you can see here what we have. So we're 99%, in this case 99.97% sure this is a face, and you can see here there are multiple indexed objects in here. So this is how I can sort of interrogate my my collection. And you can see here again, super simple code. There's anyone try to write image and facial recognition in OpenCV? Yeah. I mean, it's not rocket science, but it's not this easy. So this is like really simple stuff. Amazon does a lot of work to make our lives easier so that we can really do what matters. The fact that I can index a face in some sort of an engine, nobody really cares about that. What matters is what do I do with that face? Like what's my application logic? That's much more interesting. Amazon wants us to be spending time on those problems, not indexing faces. So they make it as simple as possible. All right, so is there anything else that's interesting here? The other thing I'll point out, this is not really a recognition thing. All of this was a serverless app that I built and deployed. You saw the architecture. In this particular case, I'm using serverless.com. So if you go to serverless.com, this is the serverless framework that I'm using. You can see I'm creating functions, multiples of them. In this particular case, there's a function, and I'm telling it that there's an API GET, and I'm telling it that the call is going to be called search faces. Over here, this is a encrypted blob. Inside of this encrypted blob is the API key for meetup.com. There's actually better ways of storing this today. I want to secure the meetup key. Obviously, we don't want everybody using my API key in this case. So I encrypted it using Amazon's key management service, KMS. Now I would actually recommend you use things like Secrets Manager, which was announced at Summit just a couple weeks ago. All right, so let's give this thing a test. Let's make some of this stuff go away. There we go. And let's see if the... unfortunately, I had to tether. For some reason, some Wi-Fi networks, my Reflector app doesn't always work. So let's see if we can get it to... All right, great. So basically, you're looking at my iPhone now. We launched the app, and you can see pretty simple interface. We tap to launch the camera, take a picture. And if everything's working, it's going to come back in just a moment. And it's able to figure out that the picture just is of me. So simple use case. Again, this is a test flight. So if you sign up, I will add you to the test flight. But now let's try a few things here. All right. So let's see if that's going to work. So, yeah. All right, so hand over your heart. Let's do that again. So, yeah, we need to try it on Darren again and see if Darren is still null. So there we go. Let's try. All right, so let's see what happens. And so, this is sort of a weird thing that I haven't yet entirely figured out why it's happening. It wasn't happening to Darren pretty much for the last week or so. So yesterday it happened to Ryan, and then I made no changes, and then it fixed it. So you want to try it?
No, I have a question.
Yep.
So if you're taking a picture of a person and there's a tag here,
Mm-hmm.
so the algorithm will return null from the face recognition, but the text recognition is more accurate.
So in this case, so you would be right, although text recognition didn't exist when I wrote this app. So my code doesn't look for text. In fact, it doesn't know how to ask for text. If you're interested, I can walk through Xcode as well and show you a little bit of what's happening behind the scenes and how this all works. But that's pretty much the demo. Again, the app is available.
Does the face recognition, does it return you more to candidate for much?
Say that again.
Does it return you more for candidates for much?
So it might. Recognition will send me back everything that Recognition thinks is a match. And then I use the confidence score to filter out people. And then normally what I do is I say, give me the first one that's above that match, above that level. That's what I've done there. So that's pretty much the demo. And I can, let's stop.
Darren's aged in the last week, so that's probably
Would you mind walking us through a little bit of Xcode?
Sure, yeah. So, all right. So you're probably going to see lots and lots of terrible Swift code. And it's mostly because I'm not a Swift developer. So the other thing that I discovered is I don't know how to zoom in on the Swift editor. So the code's going to be kind of small. And I'll try and point out. Oh, it does actually. Cool. All right, so view controller. This is my, and let's get rid of a few things here so we can see more code. All right, so this is the view controller for the main screen. So again, if you saw that interface where we tap to launch the camera, this is the view controller for that. So you can see I'm importing AWS Recognition. I'm importing Cognito. I have imported DynamoDB, but I'm not using it in this particular case. And then Alamo Fire and SwiftJSON are libraries I had to import to be able to negotiate some of the responses I was going to get. To your question on authentication, here is how I set that up. So you can see here I have a function called AWS Auth. I'm telling it that my credentials provider is AWS Cognito. I am telling it that the identity pool is this US East 1 : B4A. That's the identity of my user identity repository. And I'm basically saying, let this configuration be US East 1 with the credential provider up there. And that's my configuration. So that's basically how I authenticate with Amazon. Again, you can see a little bit of Swift code to create a image byte array. Again, that's what we need. So when we launch the camera, we take a picture. We want to turn that picture into something Recognition can understand. So we turn that image into a byte array. Over here, you can see we're saying create an instance of the Recognition client. We're telling it that the image, that we're saying image equals Recognition image. We are doing some, this by the way is force unwrapping, so dangerous code. It's not necessarily the best way to write this, but I was just trying to make it work and I didn't want to have to debug too much. And I'm telling it to grab the source image, so the UI JPEG representation. And then I do, here is the request to Recognition. So we're doing creating a request. We're sending it to this API request. So Recognition search faces by image request. This is the actual API call. Else unable to initialize. So if we couldn't authenticate or if we couldn't reach Amazon's SDK, we would get unable to initialize the request. So we set up a couple of parameters. So the request image is the image, which we have over here. You can see the collection ID that I'm going to be scanning for. I've told it that in this case it's called Rekognition Demo. This piece here is important. So over here we're saying the face match threshold, 75% confidence or better. And again, remember, I'm going to iterate through the JSON that it sends me back, and I'm going to look for the very first one that is above that number. And then I just do a bunch of, this is the actual call where we can say, you can see recognition client, search faces, by image, and we test the response. And then I have a couple of different traps. So if the error is null, you can see here, this means that there was no match detected. There is, in this case here, we detected a face, and so we will respond back with the information. And then over here, this one is no match detected, and so, or no face detected. And so I can sort of show you what that looks like really quickly. Let's get that going again. So if I launch if I reset that, and let's say I take a picture of my hand, it will probably come, or hopefully, come back and say no face detected. So it knows that there's no faces in the image, and so I built some logic into that as well about, hey, if you can't match, tell me why you couldn't match, like no faces are there. This is the function that is calling API Gateway, and what it's doing is it's taking, you can see the member ID, so we've already done the face detection. We've already asked Rekognition to give us back the ID that matches this face. Now what we're doing is we're sending this as an API, we're sending a REST request to the API Gateway, and remember there is a Lambda function on the back of that thing. We send the ID and we say go and get me the name that's associated with this ID number. And so that will come back and it'll give me the person's name. And then just some UI stuff, resetting and setting UI elements so that the app responds to exactly where we are in the execution. That's pretty much, like in terms of the Amazon stuff, that's where this was all done. So.
Your Python code that you showed earlier, where you actually use the meetup API to actually grab the images. So how is that running concurrently or preceding this code? When does that actually run? So you actually load, or have you run that already?
So I run the indexer every hour. Okay. And so I chose every hour because over the past couple days, people RSVP'd at different times, and I was just said, if I run this every hour, I'm finally going to aggregate everyone in. So that runs every hour. The face detection that's running from the handset, that is, as soon as I send the request, it's happening. If all of you had this app installed and you all did it, we would just have multiple parallel executions of that code running at the same time.
Yeah, what would be the cost of this slide?
So my indexer has been running since October, and I think my average monthly bill for running the indexer, and it was running on a much larger set of about 140 faces. It was about $6, I think, to index all the faces every month, again, at an interval of every hour. The Lambda executions are costing me fractions of pennies. So I have to run the Lambda in the thousands of times to be able to generate an appreciable bill. So it's very, very small cost. Questions?
And instead of using, for example, the meetup face APIs, I use for testing purposes, just upload like a bunch of faces.
Oh, absolutely. So I can show you a sample of that possibly. Where is index face? So here, I'm just indexing whatever the argument is. I'm telling it index this image, and it's just going to upload that single image and index it up. And then index faces. This is the Lambda code that's running every hour. I can actually execute it locally so you can kind of get an idea of what it's doing. So you're going to start to, give me 1 second. serverless. Where's serverless? So this JSON here, you can see we've just sent a REST request to Meetup, and you can see the data it's sending back to me. And then down here, you can see there are 39 faces. I just did some debug code. You know, how many faces are there? You can see I'm getting an error because I don't have a log file. And you can see here, the indexer would also fail for various reasons. And in this case, it says there's no high-res photo found, or it was successfully indexed. So I'm running it locally over here, but if I were to go to Amazon's, if I go to Lambda, for example, this is the service that's indexing, and if I go to monitoring and then I say jump to logs, you're going to see this same output we're going to see over here. So you can see the JSON that came back from Meetup, and then way down it's going to be, I'm going to have to scroll for a little while, but way down you're going to see similar stuff to this. So let's just search on success. And you can see that the same output is coming up. So this is CloudWatch logs. So Lambda, if you do a print, it's going to write that to CloudWatch logs for your debugging. So that's pretty much what I had prepared for you. Hopefully that you found it interesting.
So for the photos or pictures or videos upload to Amazon AWS, how do you know the charge for like storage?
So, let's see what the pricing looks like. So let's talk about Virginia just for a second. So that's video analysis. Sorry? Oh, free tier. Let's. Yeah, but this is all video. So let's go back to recognition. Image. Okay, so let's go to pricing. It's talking about videos, but it's not. Oh, video API. Maybe. Free tier. Oh, here we go. Image pricing. So for the first million processed, it's $1. So it's very cheap. And again, that's just how many faces did you ask it to index. So it's $1. And then you can see that we're paying for storage pricing. Let's see, API analyzes face cropped or whole images, stores a face represented in the collection, and is prorated. But it's pretty cheap. It's a penny per 1,000 faces.
It doesn't say the size of the
No, when you index it, they're doing stuff to it in the back end.
so it could be different views.
Yeah. I mean, but you're going to have to store a huge amount of photos or images before we start to really push these prices. But this is very cheap. I mentioned to you, I'm indexing about 140 faces every hour in a month, and I was maybe paying $5. So it's pretty cheap. I mean, I think if you do this at scale in the thousands or tens of thousands or even millions, sure, the price will go up, but perceived value from that should also go up. Any other questions?
Kevin, I don't think this is really a question, but the technology is amazing. I'm just thinking of all the ways you could misuse this service. Lots of opportunities for technical issues.
Well, so this is the case that we've had. I think I would agree. I mean, we could do all sorts of interesting things. We could also do things that are less than ethical with these tools. But unfortunately, that's kind of the problem we have with tools. You know, give someone a hammer, and they might go and build an A-frame. They also might go and beat someone with it. So you know, I think, and actually, this is very topical. Facebook, it's a tool. It can be used for interesting, good things. I use it because I want my family back in South Africa to have some idea of what's going on in my life. But also my information gets sold, and people do things that probably are not reasonable with that data. So to your point, yes, cool tech, we can do amazing things. Can it be misused? Absolutely.
There's sort of two parts of this. One is we could write something that's unethical or creepy. The other question is who owns the data? And I guess if you talk, you know, in this case, what kind of offer or guarantee Amazon makes that when we send that metadata up, is our data still?
So if you read the terms of service, which for those of you who have tried, works better than Ambien, because it will put you to sleep. Amazon never lays claim to your data ever, period. They just, the data that you upload into it is yours. That being said, they're a legal and lawful abiding company, so if they got subpoenaed, they may hand that data over. My response to that is, Amazon gives us probably a couple dozen ways to secure and encrypt our data. Use it. All they can do is hand off the encrypted data and say it's your problem, not ours. So my recommendation is, you know, protect your data, encrypt the data. You know, if it's benign, maybe you don't care. But for the most part, the tools are there. It's easy to do. Encrypt.
So in terms of accuracy for the recognition, if we have two objects, one is static, the other is dynamic, like moving object. In your user experience, which one return more higher accuracy?
So recognition, when I was testing it, I was able to take blurry photos of myself and get good results. I've not tested a photo against a video. So like, here's a photo of me, here's a video of me. Can it tell that it's the same person? I have not tested that. But there's no reason why it shouldn't work. Any other questions?
Thank you, Kevin.
Yep. And cool.